Welcome to today's Explainer. We're jumping right in to tackle a pretty terrifying flaw in AI security tools. And more importantly, we're building a step-by-step guide to actually fix it. Look, if you've been working with AI lately, especially in any kind of security or data-sensitive environment, you already know the promise is huge, but man, the pitfalls can be incredibly deep. So today, we're going to learn exactly how to ground our intelligence and stop our AI tools from just making things up. Okay, let's dive right into a hypothetical. Imagine you're working late. An alert comes in, and your AI security assistant confidently assures you that a critical vulnerability on your network has already been patched. You breathe a massive sigh of relief. But what if it wasn't? What if the AI just, lied? It's not just a scary thought experiment, folks. It's actually a constant, dangerous reality with standard large language models. And in our field, acting on that false confidence, yeah, that can lead to absolute disaster. To solve this, we're treating this explainer like an instruction manual. We'll cover the AI hallucination problem, do a step-by-step breakdown of RAG, look at reasoning from evidence, and wrap up with 3 clear security action items you can take today. Starting off with Section 1, the AI hallucination problem, and specifically the danger of the cutoff date. So it turns out there's a core architectural limitation to the standard AI tools we use every single day. These large language models are trained on massive data sets, sure, but that training stops at a very specific moment in time. They have a strict cutoff date, meaning if you ask a standard model about a CVE that dropped just last week, it hits a brick wall. It's literally never seen that data. So what does it do? Well, it'll either admit ignorance, which is annoying, or much worse, it'll just make something up to appease you. And that brings us to the very real symptoms of this problem. When standard models hit that wall, you start getting hallucinated CVEIDs that literally don't exist in any database. You get fabricated patch statuses, like in our late-night scenario earlier. You might even get completely made-up threat actor attributions pointing the finger at the wrong groups. In the high-stakes world of cybersecurity, relying on a system that might invent a threat actor isn't just unhelpful, it's incredibly dangerous. You need to act right now, with hard facts, not fiction. Moving on to Section 2, let's do a step-by-step breakdown of RAG and see exactly how to ground AI in reality. The crucial fix we're talking about here is Retrieval-Augmented Generation, or RAG for short. The core idea is that instead of relying purely on its locked, outdated training memory, a system using RAG actively searches for current, real intelligence from a dedicated knowledge base before it generates its answer. Basically, it goes out, grabs the actual facts, and brings them right back to you. Here are the exact step-by-step mechanics of how a system like AI ThreatLens works behind the scenes. First, when you ask a question, the system converts your query into a vector, which is essentially just a mathematical representation of the actual meaning of your question. Second, it uses that math to search a database of embedded intelligence to find the most semantically similar relevant content. Third, that perfectly matched content is passed to the language model right alongside your original question. And finally, step 4, the model uses that fresh, current data to generate a grounded, cited answer. It is such a brilliant way to completely bypass the model's memory limits. Which brings us to Section 3, reasoning from evidence and achieving real-time AI intelligence. During that crucial search phase we just talked about, the system isn't just blindly searching the web. It's scanning a massive, specialized embedded database filled with incredibly specific content categories. We're talking thousands of CVEs, known threat actors, precise indicators of compromise, and up-to-the-minute security news. It's hunting for the exact current truth within these dedicated security domains to feed back to the AI. The ultimate result of this whole process is that the AI grounds its response entirely in that retrieved information. But here's the best part. It cites exactly which intelligence entries it used in real time. So you have an AI that can explain yesterday's vulnerabilities, detail which threat actors are actively exploiting them today, and actually show you the receipts for every single claim it makes. You're never left guessing if it's hallucinating. If you take away anything from this explainer, let it be this stark contrast. Standard LLMs are simply guessing from an old memory. But RAG systems, they're actually reasoning from hard evidence. One is basically a parlor trick, and the other is a robust, enterprise-grade security tool. Let's wrap things up with Section 4, 3 security action items for executing your grounded defense. To actually protect your environment, you need to execute these 3 clear steps. Action item 1, Recognize standard LLM cutoff dates. You and your team absolutely must acknowledge the limitations of any AI you use and understand that, without help, its knowledge is literally trapped in the past. Action item 2. Demand RAG for real-time security answers. Do not settle for ungrounded chatbots when you're making critical network security decisions. You've got to require retrieval-augmented solutions. And action item 3. Utilize grounded tools like AI ThreatLens. Deploy platforms that are specifically architected to cite live threat intelligence. Because tens of thousands isn't just a big number to throw around. That's the exact scale of live CVEs, indicators of compromise, and threat actors available right now when you utilize a properly grounded tool like AI ThreatLens over at AIThreatLens.org. It's literally a massive live intelligence knowledge base working for you instead of against you. So as you evaluate your tech stack today, I want to leave you with one final, absolutely critical question. If your AI isn't citing its sources, who is really writing your security protocols? Is it a hallucinating machine just guessing from a locked memory? Or is it a system grounded in the reality of today's active threats? Thanks so much for joining me for this explainer. Stay grounded, stay secure, and I'll see you next time.